Hello everyone. Once again, welcome you all to the subject on kinematics and theory of machine. In short, we'll be calling this as Ktm, which is not a bike right now. As you already know, it's a 4 credit subject. We'll be meeting 60 hours theoretically. Practically, we will not be meeting for this time. Okay. In the last class, already we have discussed about the overview of this particular subject. What are its objectives? What are the different components we are having? What are the different modules? What are there in the modules? Okay. What are the different suggested readings that you have? What you are going to follow? Okay. Those things already we have discussed. Apart from that, we already know what are the subject pattern, exam pattern, how you are going to be evaluated, and we already had some overview of this particular subject. And by this time, all of you have already joined the Google Classroom. Okay, so all those lesson plans, course material, etc., those things are already being shared in the Google Classroom. Okay, so now coming to the history or motivation for this particular subject. Okay, so now this kinematics or theory of machine, this word fascinates us, right? So now all of we are human, yes. So as human, we have certain basic needs and we have certain advanced needs, and maybe all of you will agree with me that somewhere or the other at some point of time all of us are kind of greedy, not in the sense of suppose money, but we want comfort, we want things to happen somewhat easily, we want life to move in a better manner, we want different gadgets and all so as to do certain works and all. That means we are kind of like we always want to augment our human abilities. And now as human, as we are not gods and all, we definitely have got limited abilities. And now to do some works which are normally beyond our abilities, we should be able to augment or enhance our abilities. And now this kind of thinking, that means how I can manage or how I can develop my ability and all, and how I'll be able to do something or I'll be able to achieve something which is beyond normal human capacity. So this kind of thinking has basically led to the development of mechanisms as well as machines. These mechanisms and machine, these words nowadays only we use, but previously what happens, the human civilization in the can say during the advancement of human civilization, basically we have built up our ancient people. Okay, they have actually built something which nowadays we call as kind of mechanisms or maybe some machines. Okay, so initially basically what happened, we had certain basic needs like all those construction, or that means the homes and all, for which we have to have the construction equipments and all. Okay, so initially the thinking was to like to lift or to shift certain heavy objects basically for construction purpose and all. Okay, maybe some rocks you had in the cave. Okay, maybe consider we are living in the cave. Okay, and a particular rock for safety of ourselves, maybe from the different tigers and that kind of wild animals. Okay, maybe I want to like close my whatever is the entrance with a certain rock which is very heavy. Okay, so now in those cases how we can leave those particular things up, or maybe I have some trees, big tree trunk of the trees and all, and I want to move it or shift it from a particular location where I have cut it and to my nearest position. So those kind of thinking, those kind of requirements has basically given rise to some mechanisms like the lever mechanism, the wedges, pulley system, etc. The people are working on those things. Okay, they have somehow used lever mechanism. Okay, and they have seen that suppose if I use this kind of thing, okay, if I use this kind of thing, maybe my work gets solved in a better way. And nowadays what happens, we already have the concept of this mechanical advances, those lever mechanism, wedges, pulleys, etc. Okay, whatever they have used or what our ancient people they have used, basically in terms of our words, we are basically working in the field of mechanical advantage. That means by giving less effort, we are basically getting some more outcome. Okay, it's in simple terms it is like that. Okay, now later on what basically happen, so only having only suppose our home or having the shelter, it will be not enough. Okay, previously we used to go suppose somewhere else for suppose in search of maybe foods and all. Okay, wherever there is like the jungles and all those trees were there, and we are going there and maybe collecting our foods and all. But if the weather is not good, maybe the forest is too dense, so definitely this becomes dangerous, and it's not that much like you can say it's not good. Okay, maybe from the point of view of our safety as well as our like whatever we have. Okay, it's not good. So in that particular case, people are thinking about the irrigation. Okay, that means irrigation, mining, etc. And suppose I want to have my own field nearby my house, so I have to have suppose irrigation, that kind of supply and all. Okay, so we from there basically the concept of transferring motion and power from one form to another, this particular thing has come. Okay, so initially people were working on wind power, water power, etc. Okay, and later on like it has developed to some other. Nowadays we already know we are working on different power system. Okay, now later on also our grid increase. Now only being able to do the work itself is not enough. Now we want that whatever previously I was able to do, now on that same work maybe I want to multiply the force or the torque involved. Or suppose previously something was rotating at suppose 50 rpm, I want that it should be rotating at higher speed. Okay, maybe 1000 rpm and all I want, so that I can achieve my work faster. Similarly I want that I should be able to achieve a higher level of geometrical perfection. Okay, and a higher level of accuracy as well as precision in my work. And along with that I want to get the similar kind of thing to happen again and again. That means repeatability also is a kind of concern. That means along with this kind of concern, basically the concept of automation has come up. Okay, mechanisms and its automation. Okay, and all of you already know, if we now fast forward to the industrial revolution era, so basically that particular time has given rise to the tremendous growth of different mechanisms and machine. During that particular time only human like whatever kind of revolution we had, okay, whatever inventions we had, it has surpassed the previous all inventions. Okay, and now the people have entered in the kind of NC or numerical control era and all. Okay, now if I want to design a particular mechanical system, then I must have the understanding of its geometrical aspect of the motion and the various forces involved in the motion as well as how they are influencing it. So now in this particular course, during the course of study, we will be basically dealing with all those things. That means how, if we are going to synthesize a mechanism, how the motion should be controlled. Okay, similarly how the forces are involved and how it is doing it. Okay. Okay, I think up to this much there should not be any problem. Now coming to some basic concept. So what is this theory of machine? So this theory of machine is nothing but a branch of engineering which deals with the relative motion and forces between various machine elements. Okay, so it has basically two parts. One is the kinematics of machine and the next one is the dynamics of machine. Okay, if we now consider the subject which deals only with the geometric aspect of motion, and we don't consider the forces involved or the inertia of that particular system, then it becomes the kinematics. This word kinematics, it has been derived from another Greek word kinema, meaning motion. Okay, and now if during the analysis we consider the system inertia and whatever the different forces are responsible or involved, then this particular branch becomes dynamics. Similarly, when the system is in equilibrium under the influence of some externally applied forces, then that particular branch of mechanism is the statics, and if the system is in motion, then it is kinetics. Okay, now rigid and resistant body. So now in this particular course, basically if you can recall from the mechanics, also engineering mechanics, basically we have discussed the rigid body mechanics. Okay, and now there are two bodies, two terms. One is the rigid body, another is the resistant body. So what are those? So now a rigid body is something which is a kind of body, that means it will not undergo any kind of distortion if we apply certain forces on it. Or in other terms, we can say that if I consider a body and if I consider two arbitrary points on that particular body, then if I apply force and the distance between those two arbitrary points, it doesn't sense, then it is a rigid body. or the distance between that particular 2 points, that means it remains constant. Now, what is resistant bodies? A body is said to be resistant if it is capable of transmitting the required force with negligible deformation. So, a particular resistant body, it may undergo certain deformation, but it will be negligible in that particular work which under which or you can say the particular force or load under which it is acting. Okay, so now they can be, those kind of bodies can be considered as rigid for the purpose they have to serve. That means under that working condition it is practically not undergoing any kind of deformation. That's why we can consider them as rigid bodies. Now coming to the mechanism and machine. So now a combination of a number of rigid or resisting bodies assemble in such a way that the motion of one causes constrained and predictable motion to the other is known as a mechanism. So what is this meaning of this constraint word? So constraint means it is basically nothing but the kind of limited, or you can say predictable. Okay, that is the meaning of the constraint. It is something like, suppose I am forcing some maybe element, okay, towards the left direction, and towards the sideways it cannot move. Then I can say that sideways movement it is being constrained. Okay, that means it has been limited or restricted. Okay. So now the function of a mechanism, it is to transmit and modify a motion. Okay, and there is another definition for mechanism. So later on when we will be discussing about kinematic change and all, okay, then you will understand in a better manner. So the other definition is, if any one of the link of a kinematic chain is fixed, then that particular position forms a mechanism. Now a machine, it's nothing but a kind of mechanism, or it may be combination of mechanism. In most of the times it's a combination of different mechanisms, which what does it do? Apart from imparting motion to the parts, it also transmits and modifies the available mechanical energy into a certain kind of desired role. And so from this definition you can say that these machines, they don't produce the work, they don't produce the energy and all, okay, but the available mechanical energy into certain desired work it transforms. It is basically neither a source of energy nor a producer of work, but it helps in the proper utilization of the energy. Okay, and now the motive power, that is the power which is responsible for giving movement, it has to be derived from some external sources. Okay, and these machines are generally used to transmit both motion as well as force. So in this particular case of machine, the motions between the various links, that is nothing but the building element for a particular machine, it is successfully constant. So these different types of constant movement we will study later on. Okay, now you must know what is the machine versus structure, how we can distinguish them. Similarly, machine versus engine. So the second point, that is machine versus engine, it is your assignment. You go through maybe your books or websites and all, and find out what is the difference between machine versus engine. Next, machine and mechanism, and when we will be calling as machine and when it will be appropriate to call as mechanism. So now it will be basically based on the primary objective of uses. Okay, and when the objective is to only transfer and transform the motion and we are not considering any forces, then the system is a mechanism. And now when our prime objective is transferring mechanical energy, then we will be using the word machine. That is be more appropriate that name. And now very easily all of you can say that every machine is a mechanism, but all the mechanisms, they are not machines. Okay, already we have discussed that machine is nothing but sometimes it may be a single mechanism and most of the times it's a combination of mechanism. That's why we can consider that every machine is a mechanism, but every mechanism is not machine. Okay, and the next point, as already discussed, it is your homework. Now machine versus structure, how we can distinguish a machine and a structure. So now in case of machine, in between the different members of it we have got relative motion between them, but in case of structure there is no relative motion. Just consider, suppose your building, okay, our college building, if we have different movement, okay, if it is dancing, so what will happen you can very easily understand. Okay, similarly machine, it transforms different available energy into some useful work, but structure doesn't do any conversion of energy into work. Okay, And in case of machine, whatever members we have, they are basically used for transmitting motion or forces. And in case of structure, all the members, it takes up the loads which are acting there. And example of machines may be car, lathe machines and all, those are kind of machine. Okay, structure, bridges, buildings, etc., those are structure which are basically load bearing element. Okay, so with this we conclude for today.